Hi, I'm Damian Straszak, and I am with Aleph Zero. I would like to talk about privacy on blockchain, and specifically about one particular challenge that all the privacy systems are kind of facing, and it's the challenge of bad actors essentially using this kind of private systems to launder money. And that's what this talk is about. So let me first try to explain what's the deal about privacy on blockchains. So some people might say, well, blockchains are already private, right? So I just have some pseudo-random account which looks like a random sequence of numbers, and nobody knows that's me. And well, that is kind of correct, right? So blockchains are pseudonymous, and yeah, this is actually a good property, but of course it doesn't give you privacy really. So consider this scenario where Alice has an account and she's doing many kinds of transactions, like she's transferring some money, she's taking her tokens, she's swapping the tokens, like a whole bunch of transactions. But then at some point she decides to transfer some money to Bob, her friend. Okay, so, well, what's the issue? The issue is that Bob can see the whole history of Alice's transactions, right? And you might say, okay, it's just Bob, right? Alice, it's maybe a good friend of Alice's. Alice might not have anything to hide from Bob. But, well, that's not a good argument, because there are many other entities watching. They're observing the blockchain all the time and extracting information and extracting value out of this information, right? So these are the entities that we would like to secure the user from. Well, so you might say, okay, so here is a simple solution. Alice might do just a simple trick, right? Instead of sending the transfer to Bob directly from her main account, she could just, well, send the funds to a temporary account and then to Bob. Okay? So then Bob doesn't quite see the whole history, and, well, is it already private? And the answer is not quite. So this is a very simple trick, and the kind of entities that are interested in your information, your history of transactions, they know these tricks, right? They can easily bypass it. They have like a complicated machinery running all the time to detect these patterns, and they will be like they will know what you're doing. So this is not something that that will save you, right? But what are we trying to do here actually? So here is some kind of intuition. What is the goal here? We are trying to break the link. We are trying to break the link between the two accounts that Alice wants to use. So previously, Alice just sent some funds from one account to another and expected that there will be no one who will be able to tell that both the accounts are Alice's, right? And this is exactly what we want to achieve. We want to break the link between the two accounts so that nobody will be able to tell that this is one entity behind both. Okay? Awesome. So how to do that? Well, there is one well-known solution to this problem actually, and it's working. And it's to send the funds to a third party, okay? And then ask the third party to give you the funds back, but on a different account. So who is this third party? Typically, it's a centralized exchange or some such entity, right? Which is an entity that, well, you can trust, but it might hurt you, right? So maybe it is not an ideal solution to the problem that we have at hand. Right, so how to solve the problem in a different way? Well, just use the moon math, right? This is what you have probably seen already. You can build this kind of anonymity pool. This is how I will call them today. which are essentially some kind of containers for users' tokens. And the way to build them is using cryptography, and in particular ZK snarks and this kind of zero-knowledge proof technology. The way it works is Alice deposits some tokens to the anonymity pool, and then after some time, which is kind of important, she cannot just withdraw immediately, she withdraws to a different account, and because of this magic of zero-knowledge proofs, no one is able to link the two accounts. Okay? And this is essentially how all these privacy protocols work. Of course, there are like certain differences, whether you can transact inside of the anonymity pool or not. Like these are the main differences, but Tornado Cash, ZCash, Aztec, they're all very similar to that. They all match this kind of a pattern, right, to gain privacy. Awesome. So in this talk, sadly, I will not explain snarks. I will not explain the moon math, because I think there are like excellent resources on that already, which have been created over the last 2-3 years. Like you can take a look at the MOOCs, specifically the blockchain MOOC, the ZKP MOOC on YouTube, and they are really excellent for learning all these things. Great. So now the question you might ask is, okay, so let's say we can do that. We can break the link. Is this already giving us privacy? And my answer would be kind of. It gives us anonymity, which is basically the ability to send many transactions without the outside observer being able to link the transactions together. But note that the transactions are still public, right? That the contents of the transactions are public, in particular the values and so on, right? So actually in the previous talk this was also mentioned, and there was a term shielding and privacy, right? And this is the same thing. I just called it anonymity and privacy, but the concept is the same. So I will not talk about privacy, like the full privacy today. I will only talk about anonymity. But obviously privacy is also important, and it's also something we work on. Great. So, well, I just try to explain why privacy is good and why I want it, but here is a reason to kind of have some doubts. Like what we have observed over the years of such protocols existing is there are some problems with them as well. And most notably, Tornado Cash has been used for laundering money, and well, this is not something that we want, right? So ideally, we would like to let the legit users, right, to use the system, to use the anonymity pool, and kind of don't let black hats, the bad actors, in. And yeah, this sounds tricky, and it is tricky. Yeah, I will talk a little bit about that today. And essentially, I would like to give you some kind of a survey, what is known about these problems, what are the known approaches, what works, what doesn't, and so on, so that we have some, we gain some understanding about this problem. Great. So the first idea here would be to use a trick called voluntary reveal, right? So what we will do is allow Alice to generate a specific cryptographic key upon withdrawal from the pool, which allows any party that has access to this key to see the link, okay? To see that Alice used this account to deposit and then used the other account to withdraw. Okay, so this is kind of useful when it comes to some audits, like Alice wants to prove the source of funds, and she can just reveal selectively to someone who she trusts, right? So this is some kind of a way to let Alice keep her data, keep ownership of her data, and let her do what she wants. The bad part of this idea is that, well, guess whether black hats will reveal or not. well, you guessed right, they will not. There is nothing that forces them to reveal, so they will just keep the information private. So this is not really helping us with this particular problem. So let's try another idea, which is known as proof of innocence. So this is the variant on deposit. So the way it works is we have some kind of a blacklist. Maintaining this blacklist is kind of a challenge, but let's forget about it for a moment. And upon depositing the funds, Alice goes through a blacklist. I mean, the contract essentially checks the blacklist whether Alice's account is there. And if it is there, it doesn't allow Alice to join. And then, well, when she wants to withdraw, she just withdraws normally. And yeah, if you think a little bit about it, then you can kind of realize very quickly that it's actually stupid, because what the black hat will do, it will just, right before deposit, it will just send the funds to a fresh account and just deposit from this account. So it's like, it's not helping much, and this is not a good solution. Another idea is to do a similar thing, but on withdraw. Okay, so proof of innocence. So now, instead of doing this on deposit, you do this check on withdraw. So when you are withdrawing, your account from which you deposited, like this is kind of important, this is the first account, the deposit account, is checked against the blacklist. If it's there, you cannot withdraw. And well, this is a little bit different. It works a little bit better because, like, the reason is that now the black hat cannot really wait forever for withdrawing, right? They are kind of forced to withdraw very quickly, and yeah, it's kind of annoying. Right, so is this a good solution? Well, I would say it has some good properties. It is not solving the problem right away, but yeah, it gives some hope, right? We might use it to do something good. Okay, so what's the problems? Like, one problem is that this blacklist needs to be updated very frequently. So for instance, if not, then the black hat could just deposit and withdraw right away, which is maybe not great for privacy, but still it's kind of annoying that he can even do that. Because, yeah, his account might not be on the blacklist yet when he's withdrawing. And there are many other annoyances that, like, maybe the black hat might troll us and split the funds into like thousands of accounts and then deposit. It's kind of annoying to maintain the blacklist. Right. So here's another idea, volume limiting, and this is essentially saying we make the restriction that each account is allowed to deposit only up to a particular amount, let's say 10K USD. And well, this sounds good actually, because this is a way to, because black hats will come with like a large amount of money. They will come with millions, not 10K. And normal users, they will probably come with 10K, maybe 20K, something small, right? So this is looking like it works for regular users and doesn't work for black hats. But obviously, this doesn't work either, because black hats are smart, right? They will just create thousands of accounts and split the hacked funds into them, and so this is doing nothing essentially. So the good part is nothing, but it's annoying and it doesn't work, right? So it's pretty bad. But maybe we can do something using the same idea, but be a little bit smarter. So suppose we had such a nice kind of an ID system which has some IDs, whatever it could be, and each ID has some allowance for depositing into the anonymity pool. this allowance could be, I don't know, for a month or whatever. Like this is not the point. Suppose like we have such a thing. And what we could do is then let the user, upon deposit, reference to its own ID privately. Okay, so no one is able to see what ID is this user depositing with. And this deposit would also include a check for allowance. Okay, so if this user if this user is above its allowance, it will not pass. Okay, so well, this looks kind of good. The ID is never revealed publicly, and for this reason, the different deposits from the same user are unlinkable. Well, the issue here, of course, is this ID system. How do we get this, right? So this is essentially a Sybil protection thing. The way we solve Sybil protection in blockchain is proof of stake, right? But this doesn't work for black hats. It doesn't work at all because they have a lot of tokens. And we need a different way to solve Sybil protection and not using tokens, right? So this is an ID system that is not based on wealth. It must be based on something else, maybe some kind of reputation, maybe some kind of proof of origin of funds, maybe I would say the cursed word, KYC. Like there are many different possibilities here. And the good thing is that all these ideas, all these sources of IDs can be kind of combined into one system. Not sure how to then pick the allowances and so on. Like this is very tricky. But yeah, there is some hope, maybe, that this can be made work. Great. So what are the challenges here? It's essentially what I just said. That it's not clear how to make this, like how to create such an ID system. And then if we create such an aggregated system, merge out of a couple of components, then well, the truth is that the system is as good as its weakest component. Okay, so if there is a, you know, like a fishy ID provider, then well, you can pass on to some like shady users and it's no good. Also, like there is always this problem that maybe the black hats will then buy some IDs just to get into the anonymity pool, which is annoying, but well, possible. Of course, like this also affects the user experience. Well, you need an ID to be private. Of course, this is annoying. And from the technical perspective, you need to, like, upon a transaction, upon deposit, you always need to create these zero knowledge proofs to compute the snark proofs. And if we add like another component to the system, like an ID system, this will be obviously more complicated. And if this is more complicated, the proof is taking longer to compute. And even now, computing the proofs in the browser is kind of a pain. So like there are many challenges here, but yeah, there is some hope with this idea. So, well, so here's the conclusion. Like we have a couple of ideas for countering black hats. Like there is no magic bullet. This is something that that has to be admitted. There are many different ideas. Each of them has something new to bring, but neither of them solves the problem right away. Right? So we need to combine them. We need to find something like a combination of these ideas to make the system as user-friendly as possible and to not allow black hats. So to make it black hats unfriendly, right? So this is what we are doing on Aleph Zero in a project called Liminal, which is a privacy framework on Aleph Zero. And as I mentioned, like what I talked about today is anonymity. There is also this another layer, privacy, which is built on top, and it tries to make the transaction content also private, which we work on using multi-party computation. And that's it for today. Thanks for listening.
Yeah, thank you. Are you talking with regulators as well? Because it's all very nice in the end, but you know that even if you worked very hard in doing something that could be compliant, you have no control about on the decisions that are made, and you can be flagged as money laundering.
Yeah, so that's an excellent question, and the answer is yes. We do work with regulators. We have lawyers and talk to them. So essentially, the issue here is that if you ask a lawyer whether Tornado Cash is compliant, they would answer you yes, of course it is compliant. And it's because the law is not quite precise on that. There is lots of issues, lots of questions about like how to interpret the law. Yeah, the situation is not super clear. That's something I can say. It depends on the jurisdictions. So it's different in Switzerland, it's different in the US, it's different in other jurisdictions. And yeah, that's a big challenge. And yeah, every privacy system is essentially facing this challenge.
Any other questions? No? Seems we are good. Thank you.
Awesome, thank you.